Hi, welcome everyone. Today I'll be covering some of the topics that I've heard from a lot of biotech customers over the last few years. How do you move beyond your traditional LIMS system, traditional ELN systems? Um, what data model you can prepare? How to set up your data model for success? How to link various disparate data together when it comes to experiments, instruments, plate data, so, some of the topics that I'll cover today is what's wrong with lab databases today, why biotech companies struggle to connect data with generative AI in full swing. Like, if you don't have your data model fixed, it's really hard to use LLMs or any of the AI engineering on top of these data models. I'll also cover one real world example of like running an enzyme activity assay, then maybe talk about flat APIs and how like some legacy LIM system and ELN system have like a nested API structure and how that's kind of reducing the productivity and widening the gap between wet lab and computational folks. Um, so yeah, just a quick introduction. I'm Satya, co-founder of SciSpot, and I've seen a lot of fragmented lab databases over the few years that make it impossible to connect experiments, samples, instrument, multi-well plates, and many more disparate data together in one place. I've had the luxury to speak to hundreds of biotech companies over the last few years, and they're all run into similar problems. They start with like Excel, an ELN system, a LIM system to manage their samples, experiments. And as they grow, like their workflow gets more and more complicated, and eventually they hit a roadblock. And the roadblock is like really hard coded, rigid registries that are very difficult to connect easily. And some of the questions are like, which they ask themselves, why is it so hard to pull a complete data set from a single experiment? Why do I need multiple API calls just to retrieve samples, plates, and results? Why can't I like my instrument data connect automatically and update it to my LIM system? So these are like some of the examples, and when I like double click on it and find the root cause behind some of these pain points, it's the fundamental problem is um, you have a separate registry for each of your data points, and each of these separate registries capture like samples, assays, plates, results, instrument, but there is no like data dictionary or unique identifiers to connect them together. And traditional LIMS and ELN systems, like what they do is they build API as an afterthought. First they build as a graphical user interface, and then the API comes next. And that causes a huge issue where the sample registry is separate from the assay registry. The scientists manually copy and paste data from one system to another. The bioinformatics team write custom scripts just to like stitch data together from experiments to plates to instruments, and it's a mess. And the fundamental problem here is like API is an afterthought when it comes to traditional EL and NIM system. Second is there is no underlying thinking of how to build this as a data model. A lot of ELN and LIM system, how they evolved was they started as like a notebook entry system. Then on top of that, they might have plasmid design system. And then on top of that, they built like registries or, data warehouses. But if you take a step back, it's not like a natively built database that connect each of these together. So we'll look at some of the examples of how SciSpot is rethinking how the data model should be built when it comes to experiment design, asset design, also connecting it back to the instrument data as well. And then we'll also cover some of the aspects of like fragmented lab databases that makes it um, difficult to connect experiment samples from legacy systems and what we can do and what we can learn from that as well. And I think one of the things that comes down to is like nested API structures as well. So joining sample registry with your asset data is really hard if you have a different schema or custom registries for each of your data points. Joining results with your plate reader data also becomes difficult. Your bioinformatician might be writing like custom SQL joins to find different data sets. So let's take an example. So let's say that um, I'm running an enzyme activity assay, right? And I'm testing the enzyme activity across different substrates and conditions. So I want to track sample lineage. So what I'll do is if I'm using a legacy ALN or LIMS system, I will do nested API calls to extract data for enzymes, data for like coming from the instruments, sample metadata, and then bioinformatician might write SQL joins to pull all of this data together in one place. And that yields to like slower automation, and custom scripts are great, but somebody needs to maintain them as well, so that also introduces more complexity as part of the system as well. So you might ask, like, what is the solution? If I'm using a legacy limb system and I have these nested layers of structure built in, what can I do? So I would say, like, building a flat structure helps. I'm going to play a short GIF here where I'll talk about SciSpot lab sheets, where how lab sheet already has like pre-designed data dictionary or templates for data coming from multi-well plate readers, or data coming from instruments, or data coming as part of your assay design or execution. And then I'll also cover like how flat API structure helps here. So let's play this video and we'll see an example. So within SciSpot, you can basically create lab sheets with pre-designed templates. These templates are basically AI powered, so it learns from your interactions on what metadata works for your organization. And based on that, it recommends and builds like the first draft, if you will, for your database structure, like a staging lakehouse. And then on that staging lakehouse, you can then run scripts to be able to then publish this as a production lab sheet. So for example, if I want to upload the data from CSP, then I want to find and replace certain data points. Then I want to do data normalization. Then I can graduate this staging lab sheet to a production lab sheet. So how is this solving a problem? Rather than using a traditional LIMS system where you might build custom registries, then figure out the way to connect them, all of that is already being thought through. So each of these databases that I'm building through GUI or through API, there are references or VLOOKUP columns built into these databases. So as an example, if I go to the next slide, you will see that I can also build in, I can also inherently use some of the VLOOKUPs and reference columns. Brilliant. So in this example, I was showing you like a patient and order manager and how like they can be connected. So as you're using these lab sheet templates, whether through GUI or through the SDK that SciSpot offers, the reference column automatically links the data together. So that makes life easier, right? So you don't have to worry about setting up primary keys, foreign keys, and figure out like what does your traditional data structure looks like. You get a set template in your staging lakehouse that you can start off with, and helps you build a complete chain of custody as you're putting together your lab databases in one place. So we talked about like how flat APIs can help because you don't have like a nested structure, so you don't have to write SQL joins and do a lot of complicated wizardry on top of your databases. Also, like as SciSpot lets you create assay templates using lab sheets. So using this kind of interface, it automatically recognizes relationships between samples, experiments, and results. And I think this is what a modern biotech lab needs. If you're building something like this in house, I would recommend making sure that you have an intelligent data model and you feed off of that data model as you build your staging lakehouse, and then publish that as like a production lakehouse, if you will. You can also like utilize AI. So as you're connecting each of these lookup columns, so instead of, let's say, manually tracking antibodies are linked to which small molecules, you can automatically fill in the data, right? So AI can recognize molecular weights, batch IDs, and reaction condition. No manual input required. And then with click of a single button, you can retrieve all of the linked assay results. And as much as I like SQL and joins, I do think like a lot of this can be removed as you're building your lab data model in one place. One other example that I've seen where this is hugely beneficial with SciSpot Python SDK is automating the sample creation and plating for Tecan for liquid handlers, for instance. So I'm going to show another example of like how this flat API structure and Python SDK and SciSpot helps you like integrate with liquid handlers at a click of a button. And same thing applies to like integrating with instruments such as LCMS or plate readers as well. So let's take an example of the Tecan integration. So in this case, like what I'm doing is I'm using Python SDK of SciSpot to bring in data directly from Tecan. And what it does is like it knows the source plate and the destination plate, and it automatically creates the children for me in SciSpot limb system. And you'll see like how small of a script it is. It's almost like a one line that you can write within SciSpot. And then as you integrate this with Tecan, it would automatically bring that data within the SciSpot limb system, the alternative limb system. There's few lines of codes. I just executed it, and now what it would do is it would automatically bring the children's samples or the aliquots from Tecan to SciSpot, and it will automatically link that to the parent samples as well. So what that means is your parent samples are not only linked, but your chain of custody is maintained as well. And with this chain of custody, you don't have to like worry about writing bunch of Python scripts, SQL joins, and as you run, your assays, um, you don't have like a broken linkage downstream. So you can replace like complex limbs registries with a single unified API. And if you're building this something like this in house, what I would suggest is rather than building complex joins, think of a flat API structure. And with AI, like now you can also build graph databases. You don't have to build like a traditional Postgres or uh, hierarchical complex databases, if you will. The samples, the assays, the experiments, plate reader data, instrument data, all of this can be thought of as like nodes in the ontologies. And as you build this together, um, you can move away from the manual SQL joins to like automated data intelligence. And that's where SciSpot can help because SciSpot has lab sheets where we already have built in templates for most of these workflows, whether that's for plate readers, LCMS, or like one of the examples that I showed you for liquid handlers as well. You can read more about the SciSpot API on docs.scispot.com, or you can also book a demo. And happy to walk you through some of these use cases that I've heard from different customers. Um, yeah, and this is a way to successfully build in your samples, assays, plate, instrument data in one place, and be able to build in more automation and lab intelligence as you build a unified model. Thank you for joining today.